Okay, so that's the first question I got. I mean, if you're gonna do, and that's what we're doing separation of variables, right? Oh no, this is just straight up integrating. Okay, so yeah, I see what you had a problem with this one. So on the first one and the second one, you have to use U substitution. Okay, so hopefully you guys can see that all right. But in this case, remember, this may not work, but let's just try it. We're gonna try, normally you tend to wanna put the denominator here as U. So U is gonna be 1 plus e to the 2x. And then after that, then the derivative of that, let's say the derivative of 1 is 0. The derivative of e to the 2x is e to the 2x times the derivative of 2x, which is 2. So this is going to be the derivative right here. All right. Are you with me? So remember all of this now. Let's see, all of this right here is going to now be du. So all of that is du now. All right, so essentially what I have is du over u, where I would normally, I don't like to write it like that. I like to write it like this. Now, if you have something that when you're going to integrate this, if I would rewrite this as u to the negative 1, right? If I add 1 to the power, I have u to the 0. So that doesn't work like that. So, and I'm saying a lot of things that you may or may not remember. What I'm trying to tell you is that this right here, the antiderivative of this is the natural log of u. Of the absolute value, excuse me, of u plus c. All right, so that's one of the things you have to know. Now, at this point, I'm just going to go ahead and plug in the u, which in this case is going to be 1 plus e to the 2x plus c. Now, I think on the key, I've wrote it without the absolute value. So this part is kind of a minor part, but you still need to understand what happened to it. If you have an absolute value of this, just look at the inset here, 1 plus e to the 2x. Now, this is an exponential, and this exponential will never be negative, all right? So you can look at it in your calculator if you want, but, well, now we know a whole lot about exponentials because of this virus, right? An exponential function looks like this, right? Well, kind of like that, but it looks like that. Are you with me? So that's an exponential function. So what I'm trying to tell you is that you can drop the absolute values here because 1 plus e to the 2x will always be positive. So there's no need for me to write the absolute value anymore. Are you with me? All right, let's go on. Any questions about that? Are we good? All right, let's go on to number, what was the next one? 7, I think. 7 was a question that somebody had. So for you guys that are not interested in these questions, I'm sorry, just hang in there for a second. Okay. Yeah, 7's a little bit weird. So 7, you have this plus square root of y prime, yes, equal to 0. All right, so I'm going to rewrite this because on this, I will be using separation of variables. This is what we have, okay? Now, the whole point of using separation of variables is you got to have something on the left and something on the right, meaning I'm going to subtract the square roots of x. Let me see if that's what I want to do here. Is that the easiest way? Yeah, I don't see another way around it. So I'm going to subtract this right here to the other side. So now I have this. All right, and then now I'm going to use the separation of variables. Notice that I'm going to multiply both sides times dx. I'm just going to leave that dy alone. That dy is just going to stay there. All right, so we're solving for the general solution here. No, the particular solution. And so let me write that over here so I don't forget. When they talk about a general solution, that means that your answer is going to have a plus c at some point. When they talked about a particular solution, all right, they're basically telling you, they're giving you a point for you to solve for c. All right, so hopefully you see what's about to happen here. So this is going to be the square roots of y dy, and this one's going to be, I'm going to put the negative on the outside. Hopefully you don't mind. Square roots of x dx. All right, so that's basically where you're at that point. Okay. And then really after that, I'm just going to take the integral of each side, right? Now, I'm going to write a lot, and I know you don't have a huge amount of space. So just decide what you want to write. Okay, if you want to grab an extra piece of paper, do it. However you want to do it. So I'm gonna write a lot in case that you guys. I'm gonna try to not to skip any steps. That's what I'm getting at. I just rewrote this as an exponential, right? Square roots is something to the half power, and now we're gonna integrate. So we're gonna add 1 to the power, which is gonna be 3/2. And then when we divide this by 3/2 is the same thing as multiplying times 2/3. Plus some constant that I can just add to the right side. Okay, so let's see, same idea on this one. Except for I'm gonna have a negative here, right? Because of this negative. This negative right here, give me a negative right there. Plus C. Now again, I haven't had that question, but most of the time I always have a kid asking me, well, what happened to the C on this side? Well, if I have a constant value or a plus C, if you will, by the time I subtracted it over here, all right, I have a constant minus a different constant, which gives me another constant. Does that make sense? So this represents basically the constant that comes from here and here. So don't get too lost on that. You basically just have to write the plus C on the right side. All right, now probably the next part is going to be the funky part. We're going to plug in at this point, right? We're going to solve for y. We're going to have to solve for y eventually. But before I do that, I'm going to go ahead and plug in the 1 and the 4. So we have 2/3, 4, yeah. 3/2 is equal to negative 2/3. That's just 1, 3/2 plus C. Okay. So let's see, 4 to the 3/2, that would be the same thing as taking the square root of 4 because of this bottom part. So that would be 2, and then 2 to the 3rd power is 8, and that would be 16/3. This one's just going to be negative 2/3. Then if I subtract this to the other side, or if I add it, excuse me, that's going to give me 18/3. So C is equal to 6. You with me? Okay. So now we're going to go back to this original equation that I had here, or the general solution of the differential equation, since we want to use all the appropriate terms here. And then we are going to solve for y. Now here, I'm going to do something that perhaps seems like I'm just being retarded here. And unfortunately, that's recorded now. So my apologies for saying the word retarded. All right, so I'm going to write it as 18/3 instead of 6. Okay, now hopefully you can see why I'm doing that. Because now in order for me to get rid of those 3's, right, I can basically multiply everything times 3. Or if I want to get rid of this straight up, I can just multiply everything times. Right? Because I want to get rid of this completely. Okay? So that's going to give me a y to the 3/2. This is going to give me a negative x to the 3/2. And this one is going to give me, let's see, 3's cancel. And that'll be plus 9. Check my answer here. Yep, I'll check out. Everybody with me on that? Okay. So remember, my whole goal was to try to get rid of this 2/3, right? So I wanted to leave the y by itself. So I multiply everything times the reciprocal. Now this 18/3, really, I could have just left it at 6. I just want to get real fancy. And I did. All right, so now how do I get rid of this 3/2 powers? Hopefully, and I'm just asking a lot of rhetorical questions, right? But at this point, I want to raise both sides times, excuse me, I want to raise both sides to the reciprocal power, and that's the part you cannot forget, all right? So to get rid of this, I'm going to have to raise this to the 2/3 power, remember? And I'm going to raise this to the 2/3 power also. And this is going to give me y, and this is just going to be what this is. I can't remember if there's a key on the bottom of this or not. Hopefully there is.
There is.
How the heck do they get? Oh, okay. On the key, they just wrote this backwards. They wrote the 9 first, and they wrote the minus x to the 3/2. Oh. Okay. Does that make sense to all of you guys? Hopefully they had questions on that. Let's go on to, let's see, 9. I had a question about 9. I'm going to go ahead and switch pages here. All right. All right, so number 9. What's number 9 here? Oh, okay. Given that y prime is equal to 4y and y of 0 is 1. Sorry, that's my dog drinking water. Apparently their favorite pastime. Okay. This is sort of going to be a two-part question. Okay, so first of all, they're basically asking us, notice that it says find the value of x when y is equal to 4. Well, what do I have here? I have y prime, right? So we're going to have to solve the differential equation for us to do that. So I'm going to rewrite this as dy over dx is equal to 4y. Okay. Let's see if maybe I'm overthinking this. Hold on. No, that's right. Okay, so we're going to use the same method here. Now notice I'm going to multiply both sides times dx. I'm going to divide both sides times 4y. So hopefully you'll see what I'm doing here. I have 1 over 4y. You know what? I'm going to leave this 4 here. This is where I need Evelyn to call me a liar. All right, so we have this. Yes, and then we have 4 dx. Okay, now if you divided this by 4, it's fine. I just saw ahead of time that I'm gonna have to move that 4 either way. All right, so hopefully you guys know the antiderivative of 1 over y dy is the natural log of the absolute value of y. All right, and that's gonna be equal to 4x plus c. Okay, so hang on just a second. Okay, so anyway, sorry. I'm gonna go ahead and then plug in this point that I have here, which is 0, 1. All right, and I'm gonna try to solve for c. So let's see, we have the natural log of the absolute value of 1, which is just 1, is equal to 4 times 0 plus c. Now, hopefully you know the natural log of 1 is an obvious 0. So c is 0, really. Oh, they did that first. Okay, that's fine. All right, at this point, go ahead and do me a favor and don't write anything else I'm writing, or I'm doing it in a slightly different way than the key is doing it. I want to make sure I'm doing it right. Now, I want to get rid of this. So I'm going to exponentiate. I don't know if that's a real word or not, but I'm going to do that. So again, please try not to copy this down for now. How the heck did I get that? That's right. You can continue and copy. That's right. So this is good. So now that I have this, okay, so this is what I need in order to answer this. And that part right there is just like an algebra 2 problem. It says find the value of x, okay, when y is 4. So we're going to plug in a 4 here. And then we want to know what the value of x is going to be. So essentially what they're asking you to do is solve for that, okay? Now, hopefully you remember that the inverse of e to the 4 or of e is the natural log. So I'm going to take the natural log of both sides. And normally I don't do this part, but you know, since this is going to go on the internet forever, by the rules of the logarithms, right? By the properties of logarithms, that makes me, I can bring that 4x over here, and then the natural log of e cancels. So long story short, I end up with a natural log of 4 is equal to 4x. A lot of you normally would just go from this point to that point, which is fine by me. All right, and then finally we're going to divide both sides by 4. So I am assuming that this is going to be some decimal number. Yeah, it's 3.47. And again, I just looked at the key for that. So, but this is how you do it. Okay. Any questions about that one? Hopefully not. Okay. Let's go ahead and go to let's see, 7, 9, 10. I'm going to see if 10 is kind of the same, then I'm going to say, forget it, you do it. But no, it's not. Okay. Okay, so number 10, this is sort of that. So now at that point, it looks like once you get past number 9, it looks like it's more review of what of the whole year, okay? Or the whole semester at least. So a lot of this it's review. Of course, it doesn't mean that I expect you to remember it, but hopefully with some help you will remember it. All right, so this is number 10. Okay, so number 10, you have to do U substitution. All right, so you have to decide which one am I going to do the U substitution with. Now, what I'm going to do on here, all right, is a lot of the times, whatever function being raised to a power, that's what you're going to make U. So U, in my case, is going to be x squared plus 1. Remember what I told you when we used to have class together, is that if you mess it up, who cares? Find another U, all right? So in my case, I know this is going to work out because notice that I do have an x. See, I have a x dx here. Let me underline it for you. X dx is right there, okay? And x dx is right here. I don't need that 2 though, so I'm going to divide both sides by 2. All right, so let's replace some of this stuff. So now x dx, right? X dx is going to become 1/2 du. So I'm going to write the 1/2 here and the du over here. Okay. U is x squared plus 1 to the 3rd power. So this is going to be u to the 3rd power, right? Now the next part that I'm going to do, it's really up to you whether you want to do it or not. Okay. They're not really going to care, but it will be easier if I do it like that. So if you don't want to do it like this, go ahead and take the integral. And after you take the integral, plug u back in and then basically evaluate that between 0 and 1. But if we want to just do it all at the same time, what I can do is I'm going to put in my the limits here of this integration, if you will, the boundaries. And then let's see, if I plug in a 1 back into this, okay, if I plug in a 1 here, that's going to give me a 2. If I plug in a 0 here, that gives me a 1. Okay, so I'm going to put a 1 and a 2 now. Everybody with me on that? And then you integrate. So we have 1/2 u to the 4th over 4 between 1 and 2, like that. Okay. Now you can, if you want to, and I normally do that. Okay, you can pull, if you have a constant anywhere on here, you can pull it out. So if I pull the 1/4 out, that will give me a 1/8 u to the 4th. So that way I don't have to really deal with fractions until the very end. So that's the same thing. Okay, and then finally you have 1/8. Let's see, 2 to the 4th, which is 16. 16 minus 1, which is 15. So we got 15/8. And that's it. Okay. Let's move on to 12. Macy, I'm slowly getting to your question. Okay. Hey guys, so I have some good news. I looked at my roster, and I'll tell everybody more about it. I was looking at the roster of who's taking the AP exam and areas between regions and all that crap. Like, anything that's revolving is actually not on the AP exam this year. So, great. But this stuff will be like the, what do you call it, differential equation stuff will be on there. So anyway. Okay, so number 12. Okay, so we're finding the volume of the region bounded by the graphs y is equal to the square root of x and y is equal to x squared. Okay. Picture, of course. Let's say that this right here was y is equal to the square root of x. And this one right here, use a different color. Is y is equal to x squared. This goes to the other side too, but. All right, so we're finding the volume of the, blah, 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 blah. Okay. We're revolving this around the x-axis, I believe. Okay, yeah, about the x-axis, right? Yes. So here's the deal, all right? As we talked about before, you have to decide, the first thing you have to decide is when you revolve this shape right here, and I don't really have a pencil, but let's say that this was it. Okay, when you revolve this area right here, are you gonna get a disc, or excuse me, a solid volume, or are you gonna have a hole in the middle? Okay, now, sorry, I'm watching Macy changing her dog's diaper. So are you gonna be able to see? Hopefully you can see that this right here will have a hole in the middle if you revolve it around this, right? I don't know if you can see that. That's a hard part for you guys. So again, here's what I need to know. This part right here, I'm gonna need to know this radius, which I'm gonna, and I don't really know if you can see that. That's the big radius right there, and I'm gonna have to subtract from it the small radius. Okay, now notice that the way that I did it, right, is the line is vertically, so it's gonna be top minus the bottom. Now, when it's top minus bottom, then you don't have to change anything, right? You can just leave it the same. So essentially, I'm talking way too much here, but I'm gonna tell you anyways. You're putting a bunch of infinitely thin disc, if you will, to form this shape, okay? So that's where you want to integrate this. So we're going to integrate the shape. So remember, all of that comes from integrating the area of a circle, which in this case is pi r squared, right? All right, so let me write the formula for you in case you don't remember. This case is going to be dx. This is the volume of a disk. Okay, so that's the formula. All right, so now the volume is going to be equal to pi. Now we're going to find, we have to know what this point is, which we know is 0, 0, not a big deal. So we're going to go from 0, and we want to know when to stop, right? Because we have a bunch of infinitely thin disks that are going all the way to here. So we want to know what the point of intersection is, which I'm pretty sure is a 1, 1. All right, and if you didn't know that, you can just set x squared is equal to the square root of x and then solve for that. Okay. So that's 1. So we're going to use this right here, the x coordinates, not the y coordinates. Right now, the big radius is going to be top minus bottom. So we have the top, which is the square root of x, the bottom, which is x squared, okay? And the small radius would be the top, which is x squared, minus the bottom, which in this case is 0. Okay, 0 being this axis right here, dx. Let's see. I'm looking. They got something slightly different. Let's see why. Let me figure out if I can figure out why they have that. Yes.
On that one, I did pi and then the whatever that thing is to 0 to 1, and then the square root of x squared minus x squared to square root. Oh, that gave me the right number.
So I did this wrong. I just realized on this part right here. And it kind of brings me to the next point of the part that I forgot, okay, is that the radius, notice that I even said the radius was from this line to this line, right? So this line right here is y is equal to 0. Now, which brings me to my next point, all right? If you're doing a revolving area, please make sure that the axis where you're spinning this on, in this case being 0, is always going to be in your problem. All right, so that's a way for you to double check. That's I started to realize, like, wait a minute, I don't have the same thing here and here. Does that make sense? So again, notice that top minus bottom. Top would be here, bottom would be this line, which is y is equal to 0. Okay, and then at that point, just plug it in your calculator and see what it gets you. But that is right. I just looked at my key. Any questions on that one? I feel like I talked the most on that one. We're all doing good. All right. Let's go, move on to, I did get quite a few questions about 16C. Not a clean okay. Okay. I got a feeling that 16C was more of a, you don't really understand what they're asking. Maybe I'm wrong. Okay. But 16C is the following. Notice that they're asking you to, given that y of 0 is equal to 1, solve the differential equation analytically. All right. So what they're talking about is for you to take this equation that was given to you at the beginning of the problem, and they want you to solve the differential equation. When they're talking about solving the differential equation, what they're really talking about is basically do separation of variables in this case, right? And then solve for y, get the y by itself, and then you're gonna use that point they give you, which is y of 0 is equal to 1. You're gonna find the c value, so I'm telling you everything that's gonna happen. And then you're gonna use that to evaluate y of 1. So then they wanna know what y of 1 will be. They don't know what that is. So it's very similar to one of the problems we did earlier. Let me see what problem that was. I forgot it all. It's basically identical in terms of what we're doing to 9. All right, whoever asked me for 9. So first we're gonna use separation of variables. Now don't get confused, okay? Just leave the dy dx here, leave it alone. I'm gonna multiply both sides times dx, and that's all I can, well, and then I'm gonna divide all of that. So let me put it this way. I can't really separate that. You need to put that together, cannot separate it, cannot subtract it. If you can subtract the 1, but it doesn't help you. All right, so now we're gonna write this as the integral of 1 over 1 plus y. All right, so notice that I divided everything, okay? dy is equal to the integral of just dx, because I don't really have anything else on this side. Are you with me? So that's kind of the weird part. I can't separate that. I can't separate the 1 and the y. Okay, so now we're going to integrate. Now, it depends on you how you want to do this, all right? By that, I mean, you got to be able to realize that how do you integrate that? That's really what I'm asking you. Now, anytime wouldn't you agree that this whole thing is a function, right? Yes. Now, if I use u substitution, for example, then the du, let me move over, du would be just dy. Are you with me? So this is just dy. So what I'm trying to tell you is that this would be the equivalent of you doing this. Same thing, okay? Now, if you happen to go on to Cal 2, for example, all right, like my BC kids, normally by the time they see this, they've done it so many times, they recognize it. Sometimes, most of the time, all right? But this is just gonna be the natural log. The natural log of the absolute value of 1 plus y, all right? So notice that I could have written the absolute value of u, but I'm gonna go ahead and skip that step and at least get to this. Now the integral of this is just gonna be x plus c. Okay. Now at this point, you can do it like I did number 9 and go ahead and plug in the point, or you can just go ahead and try to solve for y. All right. So to solve for y, we're gonna exponentiate. I don't know if that's a real word. I know I keep saying that, it kind of bothers me. All right. So we have 1 plus y here, and this is gonna be e to the x plus c. Now, I talked about this in the previous video, but essentially remember that this right here can be rewritten as e to the x times e to the c, right? Remember, go backwards. These are the rules of exponents, right? When I multiply, as long as I have the same base, then I can add the exponents. Okay, now, after that, just remember that this right here, you can call it a different letter if you like. I don't care. You can call it D for all I care, right? But my point is that this right here is just going to be another variable. Excuse me, another constant. All right, so let me erase that for a second. So I'm going to call this other constant just C. Again, if you want to call it D, by all means, don't care, all right? Now, the only thing that's a little bit different with this one is that I have this one hanging out here. So this is C e to the x minus 1. Okay. Let's see. And then now, I'm going to try to figure out what the C value is. All right, so I'm going to come over here, and I know I'm writing a lot. You decide how much you want to write on this. Y of 0 is equal to 1. So y is 1, and x is 0. Minus 1. And then I'm going to solve for C, right? So this is C to the 0 is just 1. So this is C minus 1. So C is going to be equal to 2. So now I have this fundamental equation that I need to solve this problem is 2 e to the x minus 1. Okay, now they're asking you what e to the 1, or excuse me, we did all of that crap, okay, to figure out what this is. So now I'm going to plug in a 1 for x. That's where that 1 goes. And that's what that is. Now, if I plug that in my calculator, right, y of 1 is equal to 4.437. Okay. And let me see what they're asking there at the end. Does that agree with the... Now the final question says, does that value agree with the Curviest sketch in part A? Let me look at what they did on part A here. Y of 1. Okay. Okay. I think if I understand what they're trying to say, all right, so I'm going to try to do my best now. And I think you have the key for this anyway, but whenever you did your slope fill, you had something that hopefully looked like, does it give you a 0.01? Yep, okay. Kind of gives you something that looks like this, right? Are you with me? So what they're trying to make you understand is that what the slope field does for you is that this is supposed to be y. This right here is supposed to be y is equal to 2 e to the x minus 1. Are you with me? That's what you just found algebraically here, where here you did it with the slope field. Are you with me? And they're asking you, and I'm not really sure you could even tell. I don't think you can tell that because that's not big enough. Because this is 1, so okay, it'd be off the thing. But essentially, you would have a y of 1 would be right here. They're asking you if the y value agrees with what you have, around 4.3. And it kind of does, because it kind of goes off the graph. Does that make sense? So there's not really much you can do on that one. So that last one is just mainly the part about understanding. Do you understand what I'm saying? They're asking you if this y value is going to match what the y value would get at 1. Okay? All right, go ahead and at least a few of you unmute yourself and let me know if that makes sense.
Okay. Yeah, that makes sense.
Okay. I think I cover all your questions. Does anybody have any other questions?
I have a really quick question. Okay, so on number 1, I got would it not be negative log to the absolute value of 1 plus sine t plus c?
All right, what did you get again?
And like I got the answer, but it's all negative instead of positive. Why is it positive?
So I don't see how you could, on number 1?
Yeah, so my u was 1 plus sine t, and then my du would be negative cosine t, right?
Well, the derivative of sine is positive cosine. That's why.
Oh wait, I was thinking of never mind.
Everybody, don't get me wrong, that happens to me also because we have the derivatives, antiderivative. Sometimes I get them backwards. So yeah, it's important, right? I always have my derivatives memorized for the trig functions, and then I just have to know the antiderivatives are backwards, because otherwise I do what you just did, where I get the negatives and positives switched. But that basically solves your problem, Michaela, right there. Anyone else, guys? All right. Let me stop sharing here. And let me stop recording.